In this video, we're going to look at another example of sketching the graph of a piecewise defined function. So again, the very first thing we're going to do here is find the domain of the function, and that's going to give us an idea of which portion of our rectangular coordinate system the graph is going to cover. So if I look at the top piece of definition, I see that that top piece is defined for x is greater than or equal to -1, but less than 1. So if we think about it in terms of a number line, we know that we're going to occur between -1, including -1, and 1, not including 1. So this top piece of definition occurs through all of these x values. The middle definition is defined only for x equals 1. So that's going to cover the 1 value. And then the bottom piece of definition occurs for or exists or is defined for anywhere that x is greater than 1. So that's going to cover all values greater than 1. So if we look at the three pieces of definition combined, we see that in this case, they do not cover all real numbers of x. Instead, they cover everything from -1 to infinity. So the domain of this particular function would be from -1 to infinity, including -1 because x can be equal to -1 in our top definition. So now that we have found our domain, we are ready to start determining how many different pieces of graph we're going to have. In this case, there are three definitions, so there's going to be three pieces of graph. The top definition is a linear function because x is raised to a power of 1, so that's going to have the basic shape of a line. The middle piece of the definition here is defined with just a constant, which implies that it's a horizontal line. However, if you look at the x values, since it only exists for a single x value, then rather than being a horizontal line, it's actually going to be a point. Since it is only defined for one x value, then it's only going to be a single point. And then our bottom piece of definition is x squared, which makes it quadratic, and that tells me that I'm going to have the basic shape of a parabola. Now keep in mind, it may only be a piece of a parabola, so it may not look like a full parabola because it's only defined for some x values, but that still tells me I'm going to need at least 3 points to be able to sketch the graph. So let's start with our top piece of definition. We have a line, so that tells me I need 2 points. And in this case, I have two values that have to be plugged in. I have the lowest x value, or where it's going to start, and I have the highest x value, or where it's going to end. So these are kind of nice because it tells us exactly which numbers to plug in. So I'm going to find f of -1 by plugging -1 into the top piece of definition. So I have a -1 plus 1 is equal to 2. So I have the point -1, 2. And because that x can be equal to -1, this is going to be a closed point. The other value that we must plug into the top piece of definition is 1. Because that tells us the exact point where it's going to end or terminate. So I have -1 plus 1, which is 0. So I have the point 1, 0. Don't be careful here. Don't accidentally plug in a -1 because -1 is not what we plugged into the function. We plugged in a +1, so it's going to be a +1, 0. And because x cannot be equal to a +1 for this piece of definition, it's going to be an open point. I also know that this piece of definition is only defined from -1 to 1, so that tells me that I am not going to extend my graph, and let's move that back. I'm not going to extend my graph past either of these points because the graph doesn't exist outside of these x values. So I have a closed point at negative 1, 2. I have an open point at 1, 0. And I connect the two with a straight line. So there's my first piece of graph. Let's try to see if we can make that point a little better there. There we go. Now we're ready to move on and look at the second piece of graph. Well, if you remember, I told you that the second piece of graph is only going to be a point because it only exists for one x value, and that point has an x value of 1 and a y value of 2. So for the middle piece of graph, we're going to have a single point where we plugged 1 in and we got 2 out. So the point 1, 2. And because x is equal to 1 there, it's going to be a closed point at 1, 2. Last but not least, we need to do our third piece of definition. And the third piece is a parabola because it's an x squared. So we have to make sure that we find at least 3 points for this particular piece of the graph. We know that we need to plug in 1 because that is the starting point for our graph. X is greater than 1. So we're going to plug in 1 to the bottom piece of definition. So we get 1 squared is 1. So that's the point 1, 1. But again, x can't be equal to 1 in this case. It just has to be greater. So this is going to be an open point. So we're going to have an open point at 1, 1. Now we need at least 2 other points to be able to graph the parabola or the piece of the parabola. And since there are no other values given to us, we can choose any value we want to as long as it is greater than 1. So I'm going to use 2 and 3. So 2 would be 2 squared equals 4. So I would have the point 2, 4. And because 2 is greater than 1, this is going to be a closed point. And then I have f of 3, which is going to be 3 squared or 9. So I have the point 3, 9. And again, since 3 is in the domain of this bottom piece of definition, 3 is greater than 1, it's also going to be a closed point. And what we're going to see is that this one's actually going to be graphed a little bit off our coordinate system, and that's okay. So we have 2, 4, and we're going to have a point there. And then we have 3, 9, which this is 3, 6. So 3, 9 is going to be up here somewhere. And so let me fix this one just a little bit. I've got it a little too far to the side. And so now we're going to connect these with a curve because remember, this is a parabola, so it should have a little bit of a curve to it. It's not going to be just a straight line. Now you'll notice that it's only a piece of a parabola. If the rest of the parabola were to go on, it would go on over here on this side, like this, it would go up, but it's not defined for that, so we can't actually draw that piece in. And I'm going to put my point back here that I accidentally erased. And that's supposed to be open, So now that we have the graph or a sketch of the graph, we're ready to find the range. Remember, range is based on y values, and we're looking at all of these y values put together. So in this case, the lowest y value is going to be down here on the x-axis. So here is the lowest y value, which is a value of 0. I'm going to write this up here since we're kind of out of room. But notice that it's an open point, so we are not going to include 0 in the range. That's the starting value, but it doesn't actually get included. And then if we follow the pink piece of the graph up. That goes up to y equals 2, and then y equals 2 starts, the orange graph starts at y equals 2 and goes on up until we have, oh, and I forgot to put my arrow at the end, didn't I? So with this piece of parabola, because x can be anything greater than 1, this is actually going to continue going forever. And that's the reason it's important to put that arrow on there, because then when you go to do your range, if you forget your arrow, you may be tempted to stop at that point. So in this case, it's going to go on forever. So my y value, my highest y value is going to be infinity. If there are gaps in the y values, then you're going to have gaps in your range, and you're going to have multiple intervals union together. But in this case, all of our pieces of graph overlapped on y, so it was okay. Another thing that you want to do when you are graphing a piecewise defined function as a real quick check is when you get finished with all of your graph, you want to make sure that it passes the vertical line test. Because if you chose incorrectly on open and closed points, this line right here would fail the vertical line test. So if you had accidentally thought that this pink point right here was supposed to be closed, then it would fail the vertical line test, and that would tell you that you did something wrong somewhere along the way. So always do a really quick check there at the end and make sure that your graph does in fact pass the vertical line test.